Let's go ahead and get ourselves started for today. Today we got a lot of fun stuff to take a look at. So we want to go ahead and maximize our time. We're going to be looking at the whole issue of optimization today and how we can go ahead and use this Dynamo scripting language to really iterate through a whole series of different values, get results from a Revit model, and then use those results to help figure out really what some of the optimum points are, things that either maximize something or minimize something, somehow drive a behavior that we're looking for. We're looking at kind of a single variable, but then starting to generalize it about multiple variables and how we can kind of be optimizing many things at the same time. As we get going, let me just check in with you a little bit about the assignments and how that's all been going. We're just about to roll out assignment 3, and I have an idea for that. Raj and Pratush and I have to kind of write it up, but I have an idea where that's going to be going. But I want to kind of check in with you about just, the amount of time you're spending on the assignments, and does it feel about right? Does it feel like, oh my God, I'm dying and these things are so hard, I don't have time to breathe? Or is it, just what's your sense about, so are they kind of about right, or a little too much, or a little too little, or how are you sort of feeling about that? Because it helps, this is sort of a new course and sort of a new types of assignments. So I'm trying to get a sense of, does it feel about right, or are you killing yourselves, or what do you think?
I think they're about right.
About right? How about for you? About right? Yeah? Sure. No, exactly. We're sort of working on that. I think what's going to really happen between now and the end of the quarter is we're going to have it's probably pretty much one a week or something like that, just kind of plugging through there. Work out the rhythm and all. But then in terms of the amount to do each week, it seems like at some level we're trying to do things that you've seen in class, but still the opportunity to apply them. But something a little bit more. Okay, very good. Okay, the next one, which we'll actually sign out later today, probably, is going to be all about calling it planes, trains, and automobiles. What we're going to be doing is just looking at the whole issue of that. Well, we built that parametric stadium, and that parametric stadium, which used a bunch of different trusses and panelized. We can go ahead and generalize that a little bit and start to think about really almost any linear structure. So what you're going to be doing as part of that, and again, we'll write this up, is continuing to go through and look at this whole idea of these arcs, which could go through and generate trusses. Let me grab a different pen here. Okay, so we have all those different arcs, which were then generating some trusses. And we're going to be looking at really just applying that to a linear system. So going through and having a series of different lines, just applying that same sort of truss structure. Okay? But doing it in such a way that we can do it at different scales. That same sort of structure could be applied to something as small as just a shelter for cars that are being parked. It could be applied to something bigger, like a train station, or something that's very linear along a set of tracks, like a bus station or a train station. It could also be applied to something as big as like an airplane terminal. A lot of the major architecture we're seeing today really has that kind of form to it. So it's really all about kind of taking a series of different lines, running those lines, putting points on those lines, and then putting a series of different trusses that follow that, and then panelizing that system. Okay, so along the way, just the variations we'll sort of start to introduce to it are things like these lines we can start with just being straight lines, but then we can start to add a little variation to the lines to add a little more architectural interest. So as opposed to the lines being perfectly straight, we could, for example, say that one of the lines is going to be something like a sine curve or something like that to give you a little bit of a wave to the overall surface that you're putting together. To add just sort of a little non-linearity to it. We could also do things like bow out that line. There's a lot of things we could do to go ahead and kind of control the overall shape of it. But the other thing we'll do within the assignment is really take a look at all the panels that you'll put on that system and really evaluate them in a couple of different ways. What we'd really like to do is kind of take a look at two different functions, sort of the whole notion that really based on the directness of the sun, that you could go ahead and add solar panels, okay, to the panel components, use one that actually includes a solar panel and turn that feature on for ones where it would make the most sense. Okay, and for the ones where that wouldn't make sense, to go ahead and instead maximize the view. Okay, or put some sort of shades. So on a structure like this, that might be a good solar panel surface. Maybe even up to there would be a good solar panel surface. But by the time I get down here, these are probably more openings that have some sort of shading elements on them, just to kind of like provide view, okay, but we don't really need them to collect sun. Okay, so how we can just really evaluate the whole surface in terms of thinking about really what the best use of that surface is. Okay, so that's where we're going to be going with that. We'll write that up tonight. But if you want to get started with it and just kind of thinking about it, just start with that whole notion, like the parametric stadium, of just stringing out a series of 4 lines, running those different trusses between them. Okay, and give yourself a little bit of control to start waving that. Okay, and you get a head start on all that. Does that make sense? Okay, so that's where we'll go for the next one. In terms of where we were last time, we have this whole issue there of, okay, we went ahead and looked at that kind of stadium, we added all the risers, we did all sorts of things to divide up the surface into more and more panels to give us a little bit more control, then ultimately started changing the color and changing the opening characteristics based on this whole notion of the sun directness. So as we did that, you might remember there were a number of custom nodes that we were using along the way to kind of make our life easier, because as long as we go through and keep on defining little chunks of logic that we want to reuse, custom nodes are a really good way to continue to incorporate that. And you can use those custom nodes, even in your homework. So what I would recommend, let me go to the new Finder window. If you download for today, I should have mentioned it, it is on coursework, the session 11 examples, you'll find that what I've been doing is actually just continuing to gather all the different little custom nodes that we've been working on in the folder that keeps on getting a little bit bigger every session. So some of those things like, just changing the color volumes, mapping things horizontally and vertically. All those things, they're sort of evaluating the sun directness over there. Where's the color one? To map the values to the color blue to red. Those are hanging around, so feel free to use those. Okay, and start adding your own to a whole little library of those things. So go ahead and the idea is to sort of build up a library so you can kind of keep on working. Okay, what I want to do to get started with the subject of optimization is go ahead and look at that solar radiation optimizer, but show it to you so that you can actually see what happens. Since I realized after it crashed that you weren't able to see what I was talking about. So let me just kind of start with that, and we'll use that as the motivation for getting started with this whole notion of optimization. In the materials that are out there for session 11, it's example 11.1. Good day. And if we go ahead and open up that session 11.1, find it right there. Let me just show you how it works. This is one that we're actually doing in Vasari. The reason it's being done in Vasari as opposed to Revit is Vasari has a really good engine built into it for calculating solar radiation values. So we can take a look at, again, the context is we have a little cityscape here, we have a building right here. We want to orient that building so that the surface of the roof is actually getting the maximum solar radiation. So it's not sort of a simple calculation. There's a lot of work to figure out exactly how much solar radiation is hitting all the panel points and aggregate that all together. So this is something where it's not a simple formula. You actually want to use a Revit model to go through and compute something for us. And that's an example of really where we're going to be going. If our life was all about just kind of simple formulas, we wouldn't need the power of Revit and all these analysis tools to go through and figure out where the optimums are. But if we want to go through and start digging into types of analyses that are based on the actual model data, it could be structural analysis or wind analysis or energy use analysis, then we're actually going to be using Revit as a calculation engine to return more sophisticated results than just sort of simple things we can calculate with formulas. So the idea here is I've got this little building. It's kind of hanging around over there. And if I wanted to do a solar radiation analysis on it, the way it works in Vasari, and don't worry if you can't follow along right now. If you don't have it loaded on your machine, it's not going to be critical for what we're doing right now. That's a little interesting in terms of I'm looking at 2 different versions of the menu bar, which has me a little bit worried about what Vasari is doing in the background. Maybe I'll refresh that window. Okay. let me say the solar radiation tool. Here's the way the solar radiation tool works. I move that thing. What I'm going to do is choose some faces that I want to evaluate. So what I'm going to do is just choose that upper face. And then what I can go through and do is just compute based on, this is for Boston with this orientation. Those are the solar radiation values. And there's actually a whole matrix of values behind there, ranging from the high to the low. And we can aggregate all that together and sort of figure out how much solar radiation is available on the roof in this orientation. Okay, the idea is not only do we have it sort of showing here vertically, we can actually save that out to a spreadsheet and use that information. And the way that works within Vasari is we say we want to export. Then we choose some sort of path where we want to put that. Okay, and I'm going to go ahead and just put it on my desktop. I'll call it Solar Radiation 11, if I can spell correctly. It's going to be a CSV file. It'll write that out. Now, if we want to be able to go through and compute for a number of different values, it's helpful to say that, hey, we want to automatically update the export for so every iteration, go ahead and rewrite that file. Again, we're going to use that file as a little temporary holding space to sort of see how we're doing with results. I'm going to say update that. Okay, and we're ready to go. So here's what we're going to do. If we start making any changes to that building, that file is going to continue to be updated with the new values constantly. So here's what we're going to do. We are going to go through and, as opposed to us changing the orientation of that thing manually, let me kind of show you that little building has a nice little variable available to it, sort of this notion of a rotation. Okay. So rather than us tweaking that manually, what we're going to use is a little Dynamo scripting to just orient, flip between all the different orientations, kind of rotate around 10 degrees at a time and just keep on evaluating it. So let me show you how that looks. What we'll do is we'll say add-ins and bring up Dynamo. We'll open up that 11.1. Still have the old number on it from last time. Okay, you'll see it has a fairly simple little script in here. Behind this, there's actually quite a bit of complexity in a big custom node here, but let's just run it and kind of show you what the impact is. And we're going to build our own script rather than debugging this one, which is actually pretty complex. We're going to build one up from scratch. But we're going to start by just taking a family instance, and we are going to grab some sort of parameter called the increment. We're going to start at 1 and go up to 36. And what we're going to do is just save the values as we go from 1 to 36 in, it's really 10-degree increments, in a path. So to do that, what I need to do is just browse to the file where this will all be stored. I'll just go out to my desktop. See if I can find that session 11 solar radiation values. There it is. Okay, we are ready to run. Now, what I want to do is just kind of kick that out of the way so you can actually see it running. Maybe even here, pan that around. The problem with this very tiny screen is I never get everything on the screen I want to see. Okay, but I will click the run button and you can watch it in operation. So what it's doing is it's moving through in 10-degree increments and just recomputing. It's using Vasari as the calculation engine, the solar radiation tool, and for each of those different iterations, it's writing out a file, okay, as it goes around. Okay, so when it finally gets around to 360, it'll go through and say, hey, which of these different values was the greatest? Okay, and evidently in this orientation, okay, where it's kind of facing to the southwest, more or less, that seems to be the one where the roof actually catches the most sun relative to that big building over there. Okay, and that is just sort of very specific to this geometry. If we went through and, if that building weren't there, we might have a different answer. It might be more southerly. In this case, that's sort of blocking the direct south, so we have sort of a different condition. But the principle of what went on here is that we have some sort of input value we want to test. We send it on over to Revit. We let it do some calculations. We get the value. Okay. And then after we do that a bunch of times, we say, okay, which of those values was the most of whatever we're trying to drive, the highest, the lowest, whatever it is we're trying to do. And then we finally assign the model to have that position. Okay, so that's really the overall principle of where we're going today. Okay, so sir, make sense? Ah, very good. It is depending on the solar path here. Here it's a 1-year study. So this is a 1-year study, really looking at it from throughout the year from 10 to 4. So it's considering a lot of values there. So the calculation as it's doing this is really, you know, what is it? It's basically computing, it's 360 by the number of those per hour. So, you know, about 6 hours, you know, for each of those different steps. So it really computed an awful lot of data there because it did that, you know, 36 times. Okay, so, you know, and you can specify, you know, whether you want it to be all year, whether you want to optimize for spring or summer, or if you really want to just look at it at a specific time of the day, like noontime.
When it runs all the simulations,
yes,
it keeps it on record to decide which one is up.
Yes,
right?
yes.
Does it keep it after that?
You could. In this case, what it's doing is it continues to write the same file, and it's finally just adopting the one, the highest. Okay. If we wanted to sort of keep that, we could write, you know, file 1, file 2, file 3, and then we have all the different iterations. It's just a matter of how we want to program the logic. Yeah, so that may be useful to go ahead and kind of keep that. Yeah. Yes. Yeah, trees are an interesting thing to model in Vasari in that what you end up really trying to modeling is just different shading surfaces. So what we could do is almost, you know, you can create things like spheres where there's a grid or a pattern of different shading surfaces. So trees are a funny thing to model, you know, because of the way the leaves work and stuff like that. And one way that I've seen people model them successfully is to take like a sphere, subdivide it, and then give it like a patterned surface that sort of allows light to filter through. But, you know, it's a percentage of the light because it only filters through depending on where the sun's position is at different times of the day. So, but there's a whole separate, good issue about how to model trees. But the answer is yes. It's all just shading surfaces. So in this case, it's treating those buildings as a big shading surface. If south were over on this side, you know, then those buildings would be shading it instead. It's really, it's trying to be pretty accurate about it. So it's a good example in that, you know, what it's doing is it's non-trivial. It's actually, you know, pretty, ambitious about really what's going on in the background to go through and calculate those. But the good news is, you know, all these analysis tools, whether I'm evaluating the solar radiation, whether I'm evaluating the energy use in that building, because I could have looked at that as I went through the different orientations, what the energy use intensity of the building is for each of the different orientations, whether I was going to look at some sort of a wind characteristics or some sort of solar structural characteristic, you know, those are all things that we can access through the model. So that's really where so much of this Dynamo and optimization stuff is going, is how to take these geometric forms and get different types of good analysis results back that you can use to help make your decisions. Okay? So that's just to kind of motivate it. Let's go ahead and kind of talk about what we're going to do though, because that's the solar radiation optimizer. Let's talk about this whole notion of really how we evaluate things where there are many different values. So here's the deal. If we want to evaluate things in terms of many different values, there's a couple ways we can do it. Some things are actually just results from simple formulas. You know, A times B times C, 2 times, D, whatever it is. Those are very simple, and we can do those just right in Dynamo. It's very easy to sort of feed it a list of values, apply a very simple formula to it, and you'll get a new list of values. Okay. However, if we want to do something a little more interesting, like get results from a Revit model, any of these types of analyses that we might do, what you start doing is actually using Revit and either encoding logic in the Revit elements or using the overall collection of forms within Revit to return results, and you try to pull those back in. So there's two ways. It's sort of simple versus actually going after things in Revit. And when we go after things in Revit, okay, it's a little more complicated. But let's kind of just start right there. So I'm going to close this on up. I'll just open up Revit instead. Hopefully a big blank Revit workspace in here. I'm just going to do a new architectural template. I don't really care very much about what it does just yet. Gonna bring in some Dynamo. And we've been playing around with the whole notion of number ranges. I'm just going to talk about that for a second. You're going to open Mr. Dynamo. There we go. So we've been playing around with number ranges. There's number range and there's number sequence. Let's just kind of put them both out there because they're just two different ways of getting at it. They both have a start, they both have a step. The question's sort of like how you want to approach it. So let me just kind of put a couple numbers in there. I'll say that they're both going to start at 0. In terms of the step, let me go, oops, put another number in there. We got to put like 5 in as the step. Okay, and now let me put another number in there. For number range, if I put 100 in there, let me write it automatically. Okay, it's basically going to go 0 all the way up to 100 in steps of 5. So that goes through and applies that step going all the way from the start to an end. Number sequence does it a little bit differently. Okay, in terms of number sequence, let me go ahead and put another number in there. Actually, I'll use the same 100 just to kind of show you. It'll actually be a very dramatic demonstration. Okay, what it's going to go through and do is actually just create 100 instances. Okay, so it's whether you want to say start, stop, and break it up by this increment, or you want to say start, increment, and do it this many times. Okay, that's really just the difference between those two. So either of those sort of work in terms of what's going on. Let me show you a very slightly different form that every once in a while you'll see within people's models. We'll say number. And you'll see this kind of groovy form. It'll be 0, dot, dot, let's say 2, dot, dot, and I gotta remember, is it #5? I think that's it. Let's try watching that. So this is subdividing. Kind of another way of doing it. So here it was start and create as many as you need. This is kind of like start and subdivide into this many spaces between. So and 5 within there. So they're all just different ways of getting a number sequence, and really whatever one's going to work the best for you. But after you go through and you have that number sequence, no problem. We do know how we can do sort of things like formulas. And we can say that it's just a times 3, plug that number sequence in there. Okay, and it's taking a whole list and it's returning a list based on sort of a very simple formula. Okay, and a lot of times you can actually just sort of pass lists into formulas and it'll give you things. You know, there are other times where it won't. It kind of complains at you and says, hey, I don't know what to do with a list here. I'm expecting a single value there. Okay, and when that is the case, then we have to start calling out a slightly different type of logic to allow us to do that. Okay, and that's what I want to talk about over here. So there's this whole notion of really, how we get things either from simple formulas or from the Revit model. There's different strategies for doing things, and there's a couple of different strategies we want to talk about in terms of, as we think about looping through a number of different values, there's a couple of ways we can approach it. There's this whole notion of a for each loop, and that's very much like a, it's almost like a do loop. Do would have the while condition. That would be closer to the recursion. For each loop basically says, I'm going to give you a series of values, 1, 2, 3, 4, 5. And what I want you to do is for that predetermined series of values, evaluate the function at 1, evaluate it at 2, evaluate it at 3, 4, 5. So with a for each loop, you know that you're going to get a range of values to test. You're going to perform that test on each predetermined value. You know how many tests are going to be there. It's quite predetermined about what's going to go on here. Recursion is a little more interesting, though, in terms of doing things. Recursion is almost like, it's like a do-while loop, if you're in other languages. That's keep on doing something as long as something's true. Okay, and that's another way of looking at things. In some ways, that can create the same sort of logic. Okay, but it also can create other more interesting types of logic. For example, if I was going to compute the effect of sunlight or the effect of visibility on different points in a room, and as opposed to sort of saying do 100 points, I really want to figure out where do I cross a threshold. That either the sunlight got brighter or the sunlight got too little, whatever it is. What I can do is, say, hey, I'm computing. Okay, still not at the threshold I care about. Increment it a little. Computing. Okay, still not at the threshold. Computing. Getting close to the threshold. Ooh, cross the threshold. Okay, stop here. So the idea is that as opposed to doing 100 different values, you could actually target in and be very specific about it. And really, even as we get closer and closer to the threshold, we might kick into another type of calculation to go through and look at things a little more finely. So we can do sort of a gross analysis and then really start, doing a small analysis as we get in there. But recursion often allows you, because you're basing it not based on a predetermined list of values, but you're sort of dynamically adapting based on what you're getting out of the model, to be a lot more precise about what you're doing. So some of the more interesting ways of optimizing things are actually based on this notion of recursion, that we kind of continue to adapt our strategy as we go, okay, based on what we're seeing. So that's why recursion is sort of an interesting notion, and we'll sort of start getting to that. Now, in terms of doing our looping, there's a couple of new types of nodes I want to let you know about that we're going to be working with today. Okay, one is something called perform all. Perform all is something that says, hey, things don't just happen all simultaneously. There's actually an order to things. So do this first, and then do this second, and then do this third. Because what happens as we're going through and evaluating Revit models, if I set the value of something in Revit, and then I want to get the value of something else in Revit, I actually need to make sure that it sets before it gets. Because if it tries to do them at the same time, it may get before the set happens. Okay, so there actually is this notion of an order to things. And in general, Dynamo is just evaluating everything as a big flow. You don't really have any control over the timing. With perform, we're actually going to say there is a set order to things. Do this before you proceed to that, and do this before you proceed to that. Okay, so perform all does that. Transactions, another node that we're going to be using, that says regenerate the Revit model before you proceed. So what that's all about, if I say set before I go on, I want to say transaction so that it'll regenerate that model before I go on to the next step. Okay, because if it jumps ahead and the Revit model doesn't get a chance to update itself, again, you're going to be getting the wrong value. So anytime we're going through and making a change in the Revit model, you're going to find we keep on using this transaction. And what that really says is take whatever I just did and commit that to the Revit model, okay, before we keep going. Okay, next up, there's a couple of different structures we're going to use. There's for each and map. They really control the whole notion of computing things or really having a whole loop of operations happen. Let's talk about them, and I'll show you how these all work in context. Okay, for each, we've talked about a little bit. That performs a computation on each of these different input values. Okay, you're going to feed it some sort of function, and in that function, there should always be one open value. So you're going to give a list of values to test. You're going to give it a function that has one thing open about it, okay, and it's going to do those things. For each, though, doesn't return a list of results. It just goes ahead and does those things. Okay, map is actually amazingly similar. The difference between map and for each is map will also apply a function to something that is set up with a whole serial, like one open input value, okay, but it'll give you back a list of the results. So the big difference between for each and map is really for each is all about driving action, but doesn't get a result. Map also drives action, but gets a result back. It'll make more sense in context, I think. Finally, a couple of file operations that you need to know about. We have file path, that is, go ahead and put a file out there somewhere. I'll say keep the path very simple. You find I keep on putting things on my desktop or very set places. When I have exotic paths that have a lot of spaces and slashes and dashes and things like that in them, sometimes it just has trouble finding them. So I think there's a little trouble with sometimes parsing the file path. So if you keep things at desktop, or what I've been doing a lot is just naming things so that the names are all continuous as opposed to having a lot of spaces in them. It seems to be a little confusion when there's special characters and odd things in the names of your files. So watch out for that one. Then there's read a text file and write a file. We'll see how those work in just a second. But those are some of the new verbs or new nouns we're going to have to play with. Okay, sure makes sense? Okay, then let's talk about how you can actually use them. So we're going to look at a couple different models today. We're going to look at just kind of building something. The first thing we're going to do is just really try testing some parameters in a Revit model. So what we're going to do is we're going to have a very simple model that we're going to open up, and we're just going to start plugging some different values in for the height of a box, and we're going to pull out the values for the volume. So it's pretty simple. This we could have computed, but we're going to use Revit to go through and do it for us. And we're going to look at it two different ways. We're going to look at it using a for each approach, and we're going to look at it using a recursion approach. So both different types of looping structures for doing it. So let me kind of bring up the model, and then we'll talk about how we're going to approach it. So no, don't save my changes there. If you can, go on out to example 11.2, I think it is. Try that. I'm looking at the wrong class. Go ahead and open up 11.2. As you open up 11.2, you may need to, if you don't see a box right now, you may need to turn on massing and sight, and visibility graphics will turn that on too. I think I have it set up in the model that saves so that masses are turned on. But you'll see, it's just a little box element, and that box element has a couple of different interesting parameters for us to play with. It has width and height and depth, and you can see it also computes for us something called the gross volume and the gross surface area. Okay, and that's what we're going to play around with a little bit. What we're going to do as a starting point, and this is, somewhat trivial in terms of what we would expect, but hopefully we'll get the right results because of that. We're going to try plugging in different values for the height and just pulling out different values for the volume. Okay, now this would be much more interesting if this was a cone or some sort of ellipsoid or something like that. But the same principle would work. Okay, so let's just do it with a box and maybe we'll switch. So to start with, what we're going to do is, go ahead and let me go back over here. Let's talk about the logic, and then we'll demonstrate it. Here's the basic logic. We're going to start by setting up some input values. These are things that we're going to change very rapidly, about the thing we're testing. We're going to create a range of values to test. We're going to create a custom node, a function that's going to test those different values. And then we're going to just basically perform those. And when we perform them, we're going to write a report file, the first line like a title. Then we're going to evaluate each of the values to test. Okay, then we're going to basically read the report file. So we're going to set up some inputs, create a range of values, make a node to test all those things, then set up a little perform all to go through and do those different things. Okay, so for the inputs, we're going to have a couple different things hanging around. We're going to say that what family we're going to do. We're going to have some different strings for what parameter to test and what parameter to report out on. We're going to tell it where to store the files. And we're going to set up some looping values, what the first value of the loop is, what the increment is, and what the highest value is. So, 1 step by 5, go to 100. Okay. Then we're going to create a range of values. This using the number range function. Where it's going to get interesting is where we define this function that evaluates all these things. So what's going to happen in this special function is we're going to use the set the element parameter. So we're going to set something based on a value we're going to test and regenerate the model. Then we're going to get another value out of the model. Okay. And then we're going to go through and out of that, we're going to just scale it up a little bit and write it out as a string, a little comma separated string that's going to include two values, kind of the input value and the output value. So just input, comma, output. Okay, then we're going to write it out. Actually, that is incorrect right there. To the output. That's what's going on there. So that's the basic logic behind what we're going to do. So does that sort of logic make sense? Okay, if you have that as an overall scheme for what we have in mind, let's go ahead and take a look at what it looks like. So what we're going to do is back over here, go to add-ins, open up Dynamo, and let us take a look. Okay, the script for this is actually hanging around again in that session 11 folder. You'll find there's actually a couple of them. There is 11.2, that's the overall DYN environment that controls everything. But there's a couple of other things that we've set up as some little custom functions to just encode some coding as little macros that we're going to use. You're going to find one that's called get volume values non-recursive. That's the function which is actually going to post the values and get the values. So that's the one that's going to be executed on every loop. There's this little scale results for the parameter type. I'll show you that one. That's all about, it's kind of an interesting thing that I think is just a bug in Dynamo right now, where as I'm pulling out different values, it's consistently off based on a factor of like meters to feet. Okay, and when I get volumes, I have to divide through by a certain number, basically I divide through by area. It's not handling the scaling properly. But after a little debugging, I figured that one out. And finally, we're going to have a little function that will just write a CSV string. So for any comma separated value string, for any pair of inputs, it's going to basically just write a line that says input 1, comma, input 2. And the reason I set these up as separate little nodes is, these are little macros that are going to start being useful to me in my little bag of tricks. I'm going to start using these a lot in different functions. So it's nice to have some of them set up as just different little macros to reuse them. It also makes my big scripts a little bit easier to follow since there's not so much junk. It's a little easier to see the big trees, without having to look at all the individual leaves. So let's go with that. I'm going to go with 11.2. Let us take a look at this. Let's start over here on this side. These are just the inputs for what we needed to set up. And these are all just set up as a bunch of values that are ultimately going to be feeding other things. There's select the family instance, where I currently have the box selected. Again, if I want to change that to a sphere or something else, I can change it there. The parameter to test, that's just a string. It's going to be the height string. The parameter to report, that's just gross volume. Again, those are just parameter names. The file path, this is something you may need to do in terms of setting it up for yourself. If you don't have a file path right there, let me see what happens if you browse, if you can actually create a new one. I think you may actually need to go through and create a new one. So let us do this so that you give yourself, see, if it was a string, it would do it. Go ahead and do this for yourself. If you can, just go out to your Windows desktop. And, oh, what do you want to say? Just say new, like text file. I'll call it session 11. Temp values. Okay. That's just a temporary storage place. Okay, and what I'm going to do is back in my script point to it. So back over in, let me open up Revit again. I'll browse to it. Let's go to that desktop. There it is. Not much in there yet, 0 bytes. Okay, these parameters down here at the bottom are the initial value, the increment, and the highest value. So since we're going to do a for each loop for the first one, start at 20, increment by 10, go on up to some other value. So 20, 30, 40, 50, 60, up to the highest value. This slider is going to go up to 100. If it's set to 89, it'll get up to 80. It won't make it to 90. It'll stop there. Okay, but you can kind of control how much you want, what the range of the values you want. So those are the inputs. Let's talk about inputs. Seem okay? Beauty. Then let's go ahead and take a look at how this works. After you have those inputs, it's really all controlled by this thing called perform all. And what does perform all do? Perform all says, do the thing that's on the first input first, do the thing on the second input second, and do the thing on the third input third. So let's kind of just go back and see what it does. The first input is writing a file. And in terms of what that file is, it looks like I'm just taking a string that says volume values. I'm just bringing in both the starting and the ending points. So from the first point to the second point. So just putting together a string that says volumes from 20 to 80. Whatever it is in there, or 89 in this case, and concatenating them together. So that's just making a string out of all those. And what I'm going to do is just write that to the output file as a header, just something so I know what's in the output file. So that's all of it. Just string, concatenating a string is just stringing that string. Number to string is going to just basically take the number 20 and return it as a string value. 2 is a string, and this is the endpoint value. So it's just putting them all together. We go ahead and just run that just so you can sort of see it in action. And we'll evaluate that and kind of show you what it actually looks like. Okay, so that's just returning that string. Volume values 20 to 89.4. And what we're going to do is start by just writing that to a file. So if the file, there's anything in there before, since I'm just saying writing to the file, it's going to wipe out whatever's already there and just write that into the file. So it's going to clear the file and just give me a chance to go. Next up, actually, maybe I'll start with the third, go with the third one. The third one is kind of the opposite end of this. It's just read the text file. So, and in between there, we're going to do the magic. So it's going to write the file, the header. At the end, we're going to read the file. Expression 2 is really where everything happens. So the second step. And let's talk about what's happening there. For 2, here's what's going to happen. we're going to set up a little for each loop, and it's going to say, for every number on this range of values, go ahead and pipe it into this function. So the thing in gray is a custom node set up as a function. You'll see it has family instance, value to test, parameter to test, file path, and parameter to report as all these different variables. The thing that isn't hooked up is value to test. So that's the thing that's going to get plugged in by the for each. So for each is going to take all these different values, 20, 30, 40, 50. It's going to take them, it's going to plug them into this function as value to test. And at the tail end, we're basically going to get a whole list of values that are returning based on whatever it's sort of described in here. So family instance is just hooked up to box. Value to test is left blank because that's what we're going to fill in with a for loop. Parameter to test is height. That says, not only put those values, but plug them in as the height. Parameter to report is gross volume. That's what to pull out. And finally, file path to write. That's just where to put the results. Okay, so before we dive into that node, let's see, how does that feel? Does that sort of make sense? About a big function that would kind of take all those things and report them out? Okay, yes?
So what's the ordering which Dynamo usually specifics about doing stuff? Because once you get it for formal, then it goes through a certain order, right? But before then, what does it do? What does Dynamo start
I sort of think of it as being left to right.
Okay.
Okay, at least if you think about it like water flowing through pipes, it's like your upstream results flow downstream. I guess what the perform all does is it basically says, stop. Yeah, and wait for an explicit thing to happen beforehand. Otherwise, it's a little hard to predict. It's, upstream to downstream definitely works, but if two things come from the same upstream and merge, it's hard to control which one's going to happen first. So that's the trick to the whole thing. Very good question. It's like, it makes you think. Okay, let's go ahead and take a look at these get volume values function and just see how that's constructed, because really that's where all the magic's happening. There's all this stuff which is all infrastructure to get the things to happen in there, but that's the node where everything happens. And what I made was I just made a new custom node. So new custom node, gave it a name, started putting some inputs into it. I'll just say. Okay, within here I can say input. I'll copy and paste that. That's A, that's B. This is going to be a very boring node. Oops. Delete that one. I'll call that one my results. So this is a very boring node. This just takes A and B and adds it. We didn't need to set this up as a custom node. Okay, but just so you see what the function of it is, having set that up, let me go ahead and save this. I'll put it over in my session 11 goodies. Okay, with that established, what I can do now is come back over here, and I should be able to find down here, session 11 sample. So I get A, B, and result. So it'll pump it through there. That's exactly what I did in terms of creating this one. This one's just a little more complex, but how it was created, we just create a custom node, inputs, outputs, and we're going to do that a lot today. So in terms of this node, what it looks like, let's go ahead and edit it. See what's going on. On the one hand, over here on the left-hand side, this stuff is pretty familiar. This is all just these different inputs. So each of these different names over on the left-hand side, those are all matching the input boxes for the node. So the instance, the parameter test, the value to test, the parameter report, the file path. Okay, that part's kind of okay. In terms of what it's going to do inside this node, it has its own little order of operations. So within the node, what I want to do is first set on the element the height parameter to one of the values, and then I want to get the value for gross volume. So I want to do it in that very specific order. So in this node, you'll see that there is a perform. Okay, where the perform, the first step is set that element parameter. I have to transaction it so that I actually, make it generate in Revit. Then I say get it, and I transaction it so I can go ahead and pull the correct value. Out of that, I'm just going to do a little bit of mucking around with the values. So here's what I'm going to do. I'm going to take that parameter, I'm going to multiply it by this little scaling factor. And what is the scaling factor? This is just this little correction because it's reporting the values incorrectly right now. And if you even want to take a look at how that function's defined, it's pretty easy. It just says, based on the parameter type, whether it comes in as a length, an area, or a volume, either if it's a length, pass it through just as it is. If it's giving return a 1. If it's an area, I need to include this factor 3.2808. If I want to include, or I'm looking at a volume, I need to pass it through 10.76. You might recognize that number as actually being what is the number of feet per meter. Okay, so what's happening is length, it understands how to do that just fine. On the areas, though, it's only dividing by one of them, so we need to sort of basically throw in another one or multiply in another one to kind of correct that. For volumes, again, it throws in one, and we need to kind of throw in the other two for the other two dimensions. So all that function does is it just returns a scalar. It just returns a little value there. So taking that, we go to that function. We take that parameter value and I just multiply it with this little scaling value. And then I go through and I write it out. I use a function called write_CSV_string, okay, to write a string. And from that, we're going to take that string and the old text file and concatenate it. That'll say, take the old text file, add this to the tail end of the text file. So for every time it loops through here, it'll add a new row of CSV values. Then finally write the file. Now, for these functions, you can dig into any of them. There's sort of interesting little primitives to work with, and they're worth looking at, but we won't get into all of them right now. This is what it looks like when I break up or write a CSV value. I put in a carriage return, I put in the text, the data value, then I put in a comma, then I put in the second data value, and I just concatenate those all together. So somehow all that basically ends up with carriage return value 1, comma value 2. And then for the next time we loop, it's going to go carriage return value. Yeah, it's going to do that. So that's what that's all about. And again, did I have to do these all as custom nodes? Nah. But the good thing is about doing them as custom nodes, they're kind of available to me that I could then use that. I'm probably going to use that one a lot. Okay, so it does all that. Finally, out of this function, I'm telling it to go ahead and just return this string. Okay, we can actually really have it return whatever. We can have it return the file. Doesn't really matter what it returns. Ultimately, yeah, it's going to report all these things. And the real result I'm looking for is that that file is going to get written. Okay, so with all that just kind of explaining it, let's actually see how it operates and see what's going to happen. So again, what this is going to do is, if we're going 20 to 80, there are a series of values, 20 through 80. And what we're going to do is go through and evaluate that with value to test being 20, 30, 40, all the way down to 80. So it's going to do it 7 times or 6 times or something like 7 times. Okay, so when we go through and run that, I'm going to pop this out a little bit so we can see better. I'm going to sort of slide that over. Boy, is this painful in terms of, I want you to see that little box. There's really just not enough window when we're projecting in here. See if I can make that any smaller still. And maybe as small as it goes. Okay. What I'm going to do is choose that little box so you can watch the parameters change, but we're going to run it. And, well, actually, let me do this. It helps if I change the input value a little bit, just so you can sort of see what the difference is. I'm going to run it all the way up to 100. So when I run, so watch again, I'll run it again in terms of what's going on. It's going to start at a value of 20, or really, it starts at wherever we left it left. I'm going to run it. And you can see it's sort of rotating through all these different height options. And as it's going through and changing all these different height options, it's just grabbing that area, that value right there, the gross volume. So what actually happens to that? It comes over and gets written to a text file. You can sort of see the text file there. I ran it twice, so you'll see I actually have two different sets of values, one on top of each other. If I go ahead and change the input value a little bit, it would have started over and kind of wiped it out. But for the values 20 to 100, it's going through and evaluating each of those, getting up to 100. You'll notice it's not 100% right in terms of, oh, the value reported over here is 60,000. Over here it's reporting 60,000.44. And that's only because in that scaling factor that I'm putting in there, there's some rounding precision in there. It's just, it's not quite right. It's not 10.6428. I need more decimal points, and it's just not keeping them. But at least in terms of what we're trying to drive, this will get us to the right answer, or at least I don't think it'll make a difference. So the idea is, by running through this, we're going to go through, and for those 1, 2, 3, 4, 5, 6, 7, 8 values now, 9 values, it's going to go through and give us all those results. Okay. Sort of make sense? Okay. Go ahead and try and run it on your machine. If you haven't been doing it, try and run it on your machine. See if you can actually get it to run for you too. Again, the only thing that's going to really be you need is the input value or the text file where to write it. And you should be able to kind of slide that around and get it to run. And see if you can get it to set up so you can actually see the thing popping up and down in the background there. Again, if I want to clear that, if I just change these input values, either on the tail end, or actually if I want to do it more finely, I say I want to do it on an increment of 5. Let me just run that. But the good news is it's pretty quick about doing that. It's much quicker than I would have been about doing that. So it makes pretty short work of it. Okay, so now I should be going like 20 to 80 with an increment of 5. Let me come on over here and see what the result looks like. 20 to 80 with an increment of 5. So I get a little bit of finer control. Okay. Now, as you do this, this does on one hand seem kind of incredibly uninteresting because just reporting the volume of that box based on the height was something we could have just done with a formula. Okay, but it does get more interesting. If you have that down as a basic principle, okay, that opens the door to any number of things the model might be giving you. Okay. Let us do this ever so briefly. Let's go ahead and break for now, kind of come back in 5. We will continue on this with really, okay, we did it just by looping for each in a very set way. What if instead we wanted to do something more like this recursion where we systematically went and at each point decided, do we keep going or do we stop? Okay, and you'll see it's a very small tweak from what it is because the calculation's still the same. It's just the whole issue of figuring out and computing if to go or not to go to keep on going. Okay, so we'll take a look at that loop. So come back in 5 and we'll keep going.